In this lesson, we are going to see how we can use Arduino to read DC voltage. First, we are going to look at general understanding of analog voltage. Then we are going to look at number of bits, how it's calculated, 12 bits and 10 bits. And I'm going to explain how to use AnalogRead so we can read the voltages from analog pins. After that, I'm going to explain the variable resistor or potentiometer. And using multiple projects, we are going to measure the voltage from potentiometer in different ways. This course is based on SunFounder 3-in-1 Arduino kit sold on Amazon. Everything that you learn in this course is included in this kit. The course comes with tons of components and projects, all with instruction and video for smart car and other projects that you can use for school or home automation. You can purchase it from sunfounder.com. The kit also comes with full documentation, code download, learning projects with full explanation, wiring diagram, and the code that you can download. The link to purchase the kit and documentation is below the video in the description. Welcome to Arduino course by Robojax. Now we learn about Arduino AnalogRead. So we use AnalogRead to read a voltage in a pin that is connected to Arduino. For example, we have a battery is connected, we can read the voltage of this, which will be, for example, 1.5 volts. And we can read from analog input pins, which are labeled as analog 0, 1, 2, 3, up to analog 5. And analog pins are in here and on this side of Arduino board. To remind you that digital signal is like this, we have 0 and 5 volts, so it sharply increases, and as time passes, for example, it says 5 volts, 0, it doesn't matter, so we have high and we have low. The shape will be different based on each signal. But for analog, we can read a voltage from 0 to 5 or from 0 to 3.3 volts, depending on the type of Arduino boards that you use. Here is an example. This is 5 volts and 0, and as time passes, this signal or waveform goes up and down, and in this case, if you want to read this, it will be around 3.7 volts. We are reading it, we can do it using Arduino. And if we have something, 5 volts, that is not going up and down, always it stays 5 volts, we will read it like that. So how we do it is we use our AnalogRead, and it has opening and closing parentheses, and then we can put the pin that we are reading, analog pin. So this is the analog pin number that is coming there. And the analog pins are analog 0, A1, A2, 3, 4, or 5 for Arduino Uno. Pay attention that R is capital or uppercase and A is lowercase. AnalogRead, like that. Now, how can we use it? Now, the value that this one gets is between 0 to 1023. And 1023 comes like this. 2 to the power 10 minus 1 is 1023. And because Arduino Uno has 10 bits digital to analog converter, so this is 10 bits. That's why we are getting 1023. And 10 bit means 1024 steps from 0 to 5 volts, or if you have 3.3 volt system, again 0 to 1024, a step would be for 3.3 volts. This is called analog to digital converter, ADC. And here is an example of 2 bits. We have 2 digit or 2 bits, and as you can see, we have 4 steps. 2 to the power 2 is 4. We have 1, 2, 3, and 4. And the red is the actual shape, and this is what we are reading. So it will be very low resolution or low quality. And here, this is 3 bits. 3 bits has 3 digits of 0 or 1, which will be 2 to the power 3, which is 16, and we are getting 16 levels from here up to here. reading the voltage. And if we have 16 bits, it will be so smooth, it will be so many steps, so we will get very high quality signal. Some Arduino boards have 12 bits analog to digital converter. For 12 bits, 2 to the power 12 is minus 1 is 4095, and that is 12 bits, so we have 4095 steps. The highest the bit rate, the more accurate the reading. 12 bits ADC is better than 10 bits ADC. Here are the list of boards with 10 bits or 12 bits. This is the Arduino documentation page for AnalogRead. If you look here for Arduino Uno, which is 5 volts, we have 0 to 5, 6 pins, and it is 10 bit the resolution. For Nano 0 to 7, it's 10 bits, so these are 5 volts. And for 3.3 volts, for Arduino Zero, for Arduino Mega, if you pay attention, it has 15 pins, analog 0 to analog 14. So many pins, and it is 10 bits. But analog 0, Arduino 0 is 3.3 volts, and it is 12 bits. And Dewey is also 12 bits, and MKR family boards are also. But this is 0 to 5, this is 0 to 11, 12 pins, and this is 7 pins. There is some star here. It says that the default is 10 bits, and we can change the resolution for these boards to use AnalogRead resolution to change it. Now, to print the value that we are reading using AnalogRead, we use AnalogRead A1, for example. We can use serial.println and put this inside the opening and closing parenthesis here like that. So that AnalogRead is now inside this, and it will print the value for us. And when you use it like this, for 5 volts, it will print 1023, which we are going to demonstrate. And if you are reading 2.5 volts, it will print 511. So it will not print the actual voltage, it will print this number. So how can we get the actual voltage? In this lesson, we are going to use a potentiometer or variable resistor, which has 3 pins. One pin will be connected to analog pins, in this case analog 0. The other pin will be connected to 5 volts. The other pin, the third pin, will be connected to ground. And we are going to read the voltage between these 2 pins as we rotate this knob. Here is the potentiometer or variable resistor that is coming with this kit. It has 3 pins. These 2 pins are straight. If you look at this number or label, so these are straight. So these are pin A and B, and the middle pin is in here. As you can see, it looks also at the middle. And we can rotate it with our hand, or we can use a screwdriver to rotate it to change the value. Variable resistor is in this shape, that it has long knob, and there are different color and shapes where you can rotate and get different values. And here are the 3 pins, and this is the middle wire or middle pin. There is also a sliding variable resistor. As you can see, this is dual. It has 2 pieces for stereo. When you move it, as if you're rotating 2 sliders or pushing 2 sliders simultaneously, we are increasing and decreasing the sound. But we can use it for any other purpose as well. This is another type of potentiometer where you can rotate it with a screwdriver. This is called multi-turn potentiometer, so it rotates like 15 or 20 turns before it clicks. Value here it says 103, and that 1 and 0 is 1 and 0, which is 10, and then we have 3 means 30, so this is 10,000 ohm or 10 kilo ohm. This one has labeled as 1 kilo ohm. The total value is 1 kilo ohm, and when you slide it, it goes between 0 and 1 kilo ohm. 2 are labeled as 104, so this is 100 kilo ohm each. This is 100 kilo, and that's also 100 kilo ohm. The potentiometer is shown like this in a schematic, or maybe you will see a box with 3 pins, and the middle pin, this is the pin where it slides left and right to read the value. Potentiometer has a fixed value, and then the middle pin is variable. In this case, this is 103 or 10 kilo ohm. So we are getting the value between 0 to 10 kilo ohm. And to demonstrate it better, inside the potentiometer we have a surface of carbon where between A and B is the total value of our potentiometer, and the middle one is sliding piece where you can rotate it to the left or to the right between these 2 points. When this pin is coming closer to this side, we will get minimum, because from here, in this point, it will be minimum between A and C. But if you rotate it on this side between A and C, you will get maximum, because this will be at this point, and the whole resistance will be will be considered in our calculation. And here I'm connecting this K-Weeds KM601. This is amazing auto range, automatic, very precise multimeter with reasonable price. I've done the full review. If you want to purchase it or watch the video, the link is below the video in the description. Let's connect it to the 2 pins, 1 pin on the right and 1 pin on the left. So this will give you the full range of this. This is 10 kilo ohm. As you can see, it shows 10 kilo ohm. And if you want to measure the value while it's rotating, I'm going to go with the middle pin. You see, like that. This pin is empty at this side. As you can see, it shows 3.8 kilo ohm. Kilo is here. And let me just rotate it. 1.79 kilo ohm. And then 0 ohm. Now I can go this way. This is about 8 kilo ohm. And then 10 kilo ohm. So as you can see, we can have different values of resistance based on this. This also shows in terms of bar graph. If I want to put it in kilo ohm and does not change, I can change the range from here. You see, manual, change it to kilo ohm. Now this is 10 kilo ohm. At kilo ohm, we can go less. 9 kilo ohm, 8, 7. And that's the maximum, like that. Method number 1 that I'm showing you is printing just the voltage. So this is our function, analog read from analog 1. We use serial.print, and then we put analog read in here. So this is our reading pin from analog 0, and this is 5 divided by 1023. 5 is an Arduino voltage, and 1023 is 10 bits. So we put this fraction and then multiply it. So this value, which is from 0 to 1023, multiplied by this fraction. So this will print actual voltage. Let's do the wiring. I'm going to insert this potentiometer by holding the label towards the board like that. So it's facing that way, and insert it in a straight line like this. So you see the 3 pins are aligned, and make sure that we have some holes available. So I'm moving it. Now I can see 3 holes. Let's insert black to the right one, because these 3 pins are available for the potentiometer, and the red to the left one. The middle pin is for blue, because in our schematic the blue is shown on this side. Let's do it. This doesn't have much room, but I think I can insert it. Yes, so the blue is inserted. Now blue goes to analog 0 here. Let's go to analog 0. Black goes to ground. We have 2 grounds, and the red is 5 volt. I'm connecting it to 5 volts. The wiring is done. From this lesson and beyond, I'm going to use Arduino 1.8. If I click on help, about, you will see this is 1.8.19, where you can get it from the same page that I've shown you, because in this Arduino I can open serial monitor separately. Now let's open our first project. File, open, go to download, and then SunFounder 3-in-1 learning project, and then 4.1. Turn the knob and select turn the knob.ino 4.1 and then open it. Here is our code. We are defining a variable called analog pen of type integer, and we assigned analog 0 to this variable. So this is holding the pen analog 0, and then we have an integer called val with initial 0. Then inside the setup, we initialize the serial monitor with 9600 baud, and inside the loop we use AnalogRead and then the pen. So this is reading the analog pen, and the value is stored in the variable called val. Now we use a val inside the serial.println, so this will print the value that is read from this pen. Now let's upload the code. The code is uploaded. Let me open the serial monitor. As you can see, beautifully it can be opened, and we are reading some value. Now I'm using a potentiometer, a screwdriver, to rotate this and show you also here. We are reading 507. I'm going to the left. As you can see, it's increasing as I go to the left. So now I cannot go any further, and it is 1023. If I go to the right, perhaps it is being decreased, and 0. So we are reading the value between 0 to 1023. So how can we get the actual voltage? Here there are methods. Method number 1 that I'm showing you is printing just the voltage. So this is our function AnalogRead from analog 1. We use serial.print, and then we put AnalogRead in here. So this is our reading pen from analog 0, and this is 5 divided by 1023. 5 is an Arduino voltage, and 1023 is 10 bits. So we put this fraction and then multiply it. So this value, which is from 0 to 1023, multiplied by this fraction. So this will print actual voltage. I will provide you the link. You can download it from our website, robojax.com. This is our method 1, lesson 9. This portion is exactly the same. And here I've used here AnalogRead, analog pen. We are reading the value, multiplying it by 5 over 1023, multiplying it by this fraction, and the result of this calculation is actual voltage. Using serial print, we are printing it. Let me upload the code and opening serial monitor. As you can see, we are reading 3.04 instead of that strange number. Let me change it so you can see. I go to the left, I'm reading 5 volts. Go to the right, at the middle I'm reading around 2.5. You see it's at the middle. And if I go to the right, 1.9, 1.7, 1 volt, and then go 0. So it perfectly works if you're reading it like that. Method 2, first we define a variable for DAC. Here we have a data type integer, and this is our variable that is holding from 0 to 1023, and we use AnalogRead A1. So this is reading pen analog 1, and the value of this is stored in the variable called value. Now we have it, and to print it we say serial.print, and we put the value in here the same as before. This 5 is the voltage and 1023 is the bit step, 10 bit steps. So this will print something like 3.65. And here it shows 3.5. Let me rotate this. 5, and if I go to the right, amazing. It works perfectly, shows us the voltage. If I disconnect analog pin, as you can see like that, this is now floating. That's why you see fluctuating. But if I connect this to ground, you will see 0. If I connect it to 5 volts, you will see 5 volts. And if I connect it to 3.3 volts, you see 3.63. That's the voltage that this module has. Now, method 3, we first define a variable, the same as before, value. This is data type and variable name, which is holding the value for us. Then we define a new variable called voltage of type float. This is different now. Float is a data type. This is our variable name that is holding the voltage, and the value is here multiplied by 5/1023. So from here to here, this is our calculated voltage, and we store it in a variable called voltage. So now the voltage will be holding our actual voltage that we can use. So now we can use this voltage to either display it on the screen or use it in our calculation or print it. This serial.print and then voltage. It will print 3.65. Now if you don't like this and if you want to have actual V, then in the next line I've changed this so this doesn't have ln, print ln, V. This will print 3.65, and this V is coming from here because we have double quotation. So this is just a text at the end of it. This is our third method of lesson 9. Everything is the same except inside the loop. When we read the analog pen using AnalogRead and store the value in a variable called value. Next line we have defined a variable of type float called voltage. We get the value here and multiply it by 5/1023, and the result of a calculation of this is a voltage which is stored in a variable called voltage. This can be any other word that you want, of course not void, loop, or other words that are reserved, but you can put an understandable variable. So the voltage is now printed using serial print in here. Let me upload the code. Upload it. Let's open the serial monitor. Now this is a value. As you can see, nothing has changed. It shows exactly the same, responding the same, and it's printing it. Now to make it nice, I've removed this ln that was here, and then in the next line I put V inside this double quotation, so the V is printed beside it. Let me upload the code. Now you can see the voltage with the V, so it looks nicer. Let me change the value. So when I change it, you can see the actual voltage with V. It responds very well. Now let's see if we can change the value that is displayed. If we put comma here 3, we change the number of decimal points that are displayed. So 3 means now 3 decimal places. I've explained this in the lesson where I explained the serial monitor. We have 3 decimal places. Now I'm rotating it. This is millivolts now. 1 millivolts, 10, 100 millivolts, and that's 1000 millivolts or a volt. Very nice. If you want, we can go with 1, because default was 2, so I'm trying also 1 decimal place. Now pay attention, this should be rounded 8. Yes, 2.8. and I'm rotating it.